Hi kids, welcome to lesson 5.12, Triangle Proportionality. You have a warm-up here. You need to be thinking about isosceles triangles and what you know about their base angles. And then you also have another isosceles situation here, so these angles will be congruent. So now I want you to try to figure this out. Pause the video, come back and check your work. You should have been able to find this one right here as a linear pair because this is 40, that's 40. Every triangle has 180, making this one 100. Linear pair making this 80. Base angle is 80. Okay, triangle proportionality theorem. Basically, it states that if you have a triangle like RST and you have a line cutting through the triangle that is parallel to another side of the triangle, it cuts the triangle into proportional pieces. And you can use those proportional pieces to solve for missing side lengths, like US here. So I could set up a proportion of, 10 over 4, like this piece over this piece, then follow the same pattern on the other side, 14 over X. And then I would just cross multiply and divide. Okay, here's some more examples where we're going to look at this. This is what I'm looking for. There's my X. So I can set up a proportion because I have these as marked as parallel. And then I'm going to cross multiply and divide by 12. Another example over here, I'm looking for the length of KL. I have parallel lines, so I know things have been cut proportionally. So I can say X over 18, 44 over 24, cross multiply, divide by 24 on each side, X equals 33 units. Okay, so now the converse of that says is, okay, if you compare the proportional cuts, if they are indeed proportional, then that little line cutting it would be parallel. So we're going to try to verify that. We're going to set up and say, does the proportion of 10 over 15 hold true with 8 over 12? Well, when I cross multiply, or I can reduce to see if I get the same ratio. That'd be one way. Or you can stick with the cross multiplying, and you can do 10 times 12, see if it equals 15 times 8. What you find is 120 equals 120. Yes. So, yes, DE is parallel to BC. And I could add that notation to the drawing. All right, so I want you to try these. This one you've been given that these are parallel lines and you're looking for your X here. And on this one, they're asking you to verify that the lines are parallel, but they're telling you that AC, this whole distance here, is 36. So 36 minus 20 will give you this piece. And they're telling you the whole piece here is 27. So pause the video, see if you can follow the examples we just did. Come back and check your work. Did you get that X equaled 7.5 units? And did you say yes, they were indeed parallel? And you did it right. Okay, so now let's look at another example, a couple examples here. We're asking, is this line parallel here? So I'm just going to set up my proportions, which is just two ratios. I see that as a 30, y'all. I don't know if it's a 30 or a 36. I don't think it's going to matter either way. But when I cross multiply, and these are not equal to each other, so no, these are not parallel. Try another one over here. They're telling me that this is 27, 23, 19, and 31. Set up my proportion. cross multiply. So I have that these are not parallel. Okay, find the value of x. We know that these are parallel, so I can set up a proportion because I know these cuts have been made proportionally. So I can have 7 over 10 equals x over 12. Guys, I could do 10 over 7 equals 12 over x. I could do 10 over 12 equals 7 over x. I could do x over 7 equals 12 over 10. I could do 10 over 17 equals 12 over 12 plus x. There's lots of proportions, just as long as you keep your pattern the same. Now I'm going to cross multiply, divide by 12. There you go. Okay, now this one we're going to ramp it up just a little bit. We've got a little more algebra involved. It said given that segment AB is parallel to segment DE, so I do have parallel segments. So now I'm going to set up my proportions. 42 over 9x plus 6 equals 36 over 8x plus 2. I'm still just going to cross multiply. I just got to make sure I distribute this time when I'm simplifying my equations. So when I do that, I get 324x plus 216 equals 336x plus, this is supposed to be a 2, plus 84. Okay, then I'm going to start by combining like terms. I'm subtracting the 324x from both sides. Subtract 84 from both sides. Divide by 12. And x equals 11 units. Now it asked me to find the lengths of AC and BC. So AC, remember, equaled 42 plus 9 times 11 plus 6. When I follow my math, that's 99. I got to do the multiplication first. I get 147 units. And for BC, it was 36 plus 8 times 11 plus 2. Multiply first, but you get 126 units. Okay, I want you to try numbers 1, 2, 3, and 4. So pause your video to sketch these and work them out for 1 and 2. Pause your video to sketch to work out for 3 and 4. Here's your check for 1 and 2. Here's your check for 3 and 4. Okay, the transversal proportionality theorem is much like the triangle proportionality theorem. It's just saying that you have one or more parallel lines, well, 3 or more parallel lines, cut by transversals, that the cuts are made on the transversals proportionally. So I can set up a proportion. And again, I just have to follow the right pattern. 5 over 6, 9 over x. Or I could do 5 over 9, 6 over x, x over 6, 9 over 5. I could do 11 over 9 plus x equals 5 over 9. There's lots of them. So then I'm just going to cross multiply. And I am going to then divide by 5. Okay, let's try some more examples. It says, what is the value of x in triangle PQR? Now I know that these right here are parallel, so it's cutting these lines proportionally. I've got that. I also know that if I can cut it proportionally, that these are also going to work, as far as like I could add 12 plus 4 if I wanted to. But I'm just going to take my 4 over x plus 2 equals 3 over x, and I'm going to cross multiply. 4x equals 3x plus 6. I distributed, subtract 3x from both sides, and x equals 6. Now, You could have done another one. I just want to show you the other way. I know that this is 16 because I can add these together. And this is 12. I can add those together. So I could have done 16 over x plus 2. And then 12 over x. Cross multiply. Be sure to distribute. I still end up with x equals 6. Okay, just to summarize, if the line is parallel to one side of the triangle and intersects the other two sides, it cuts the triangle proportionally. And remember, that's kind of the same thing of parallel lines and transversals. It cuts them proportionally as well. Okay, if you have any questions or concerns, be sure to hit me up on It's Learning or in class, and I will catch you in the next lesson. Have a good night.